All right, guys, girls. So coming out to you, I believe is 4.7, the worksheet I checked off. But I wanted to make sure I got to those last 4 problems on there. So let's hurry up and pass them out. Let's hurry up and pass them out.
Come on,
All right, this is number 5 on the back side, so this should be coming out if it should be coming. All right. They want us to prove that, put in blue, we need to prove, they want us to prove that MT, they want us to prove this, and this are congruent. Okay? So, let's put our givens. All right, so we want to say, they tell us this is congruent to this. That's part of the givens. And I'm going to put in green the givens. The blue is what we're trying to prove. That way I don't have to waste space. And then we know that KO and KS are congruent. And then M is the midpoint of OK. So that means that I will have to state this and this are congruent. And then T is the midpoint of KS. So we have to state that and that are congruent. So from the midpoint, so all the greens are my givens. I'm trying to prove the blues. So the givens are up here. And I can say that KM is congruent to MO. And I can say that KT is congruent to TS. And that's the definition of midpoint. Okay? So, other things that we might know. They told us, being that we knew this whole thing and this whole thing were congruent, I can say that the base angles are congruent. So then I can go ahead and state that angle O is congruent to angle S. And that has to do with us stating this. This, then we can say this. Okay? And that's good enough reason for me. Do I have enough information to prove these two small triangles are congruent to each other? Yeah. Okay, I already know this is congruent to this. I know this segment is congruent to this segment. Hang on. MO. Oh, I can't say that yet. Shoot. All right. Yeah.
Could you say angle P is congruent to angle R because of the same reason for angle O is congruent to angle S?
No, because that's not part of the isosceles triangle. Okay. What am I trying to prove? Oh, shoot. So this segment, so that should have been a double tick. That and that are congruent. That and that are congruent. I now have to prove these are congruent to each other. And I think I could do that through substitution. So I think I need to say that MK plus MO is equal to KT plus TS. I think I can state that because further up, we knew that the whole segment was congruent. Now the angle, so this is just kind of a congruent parts. We knew from givens that we say those were congruent parts. Then I could start substituting in. So I think if I go with lost it. I lost it. Yeah.
You said triangle MLP is congruent to triangle PSR.
I am going to say that yes. I just don't know if I can make that leap at this point. Can I state that though? Because we know that KO, they told us that KO, KS are congruent. I think being that we knew that from here to here is congruent to here, and then we knew we had the midpoints, that by parts has to say congruence. So I think that, I don't even know if this is necessary. I don't think we need this. I think that we can go ahead, I think we can go ahead and say that OPM, triangle OPM is congruent to triangle OPM SRT. And I think we can go ahead and say side angle side on that. And then we could say our last thing, which was PM is congruent to RT. Thank you. And that's just CPCTC. Yeah, I think that'll work. It's goofier one. So that was 5, then 6. Everyone, did all papers get back yet? Where's our stack of papers? Is it sitting on a desk? Is anyone's there? No name? Does this happen to be yours? Make sure your name's on it and I get it back by the end of the period, please. So I can give you points. All right, number 6. Similar type of idea. R or H, J, K, M. We did 6 in class?
Yeah.
I thought I did 1, 2, 3, 4.
Yeah, you only did 1, 2, 3, 4.
Right?
It was on the notes for.
Oh, this was already on the notes?
No.
Yes.
I think you're right. This was on the notes. Sweet. Thanks for saving me time. All right. Thank you. Woo! I feel better. Thank you. I tell you, I am sneezing like it is springtime. But yeah, we're gonna get like 19 inches of snow. We're gonna have snow day on Friday.
Yeah, it doesn't look like it actually.
I'm just saying. I'm just saying. All right, I can hope, right? All right, so we know that PR and ST are congruent. That's one of our givens. Again, I don't need to list it. It'll be up above. Let's pretend. NP. So this is now congruent to this. Is that okay? And then angle P is congruent to angle T. And we want to say that WRS, we want to prove that this here is an isosceles triangle. This is what we're trying to prove. We're trying to get there. None of that is proven yet. We just want to get to that point. Okay. I think the important thing to know is our first step would probably say that PR, right above that, I'm going to say that RS is congruent to RS. That's our reflexive. And then I can say PR plus RS is congruent to RS and ST. And that's kind of a segment addition postulate. Could easily state something like that, especially with the RS-RS. Which then would say, that would suggest that then PS is congruent to RT because you have congruent parts. So now I know this and this are congruent, which then by highlighter. That means that this, and then this, those are congruent. Looks like I can go side angle side for those triangles. So I have triangle PNS is congruent to triangle TBR and side angle side. Then I would say that NS is congruent to VR, CPCTC. And then I have to realize that NS is equal to NW plus WS. And I have to say that VR is congruent to VR, VW, WR. Segment addition postulate. And yeah.
And then could you say WS is congruent to WR?
Oh, you know what? We didn't even just say that. You know what? This doesn't have. Let's see. I'm erasing this. I don't need this right here. I just saw what I could do. Shame on you guys for not picking up on this. I can now say that angle RSW is congruent to SRW. So this angle is congruent to this angle because that's part of that and this. And there's CPCTC. And then of this triangle, then I could state easily that WR is congruent to WS because we knew this. Therefore, we can state this, right? Which then tells me that triangle WRS is isosceles. And that would be because I guess we could use the same reason. We have this is isosceles. Do you like my little fun S at the end?
That's nice.
I knew you liked it. And then number 8, last one. All right, so our givens HJ and MK, those are congruent, sweet. And angle HJK, this angle here is congruent to this angle here. Then I can state that JK is congruent to itself. That's our favorite. What are we trying to prove? JOK is isosceles? Okay. So, we're trying to show that this is isosceles, but I can state what?
Or like do something with angle subtraction property.
Oh, yes, I like what you're saying. This is what I think I really like what you're saying. I wanted to try with this one thing just to see if this works. So if that's H, J, and K. And then this is the other triangle. That M, K, J. Now that to that to that. Those two triangles are congruent because of side angle side. I just wanted to pull them apart just so we could see it. So I can say that triangle HKJ is congruent to triangle MKJ because of side angle side. which then that's going to allow me to say that HK is congruent to JK, CPCTC. I think there's a number of ways that we could go through and start stating that. So we can either focus on the angles, like you said, or we can focus on the segment. So either way, it's going to work. Let's go with segments. So
Oh yeah, I did that.
HKJK. Yeah,
Is there any way you could say OJK?
OJK. Angle?
Yeah, it's congruent to OKK because of congruent points. Is that instead of doing that, I'm going to say OJ is equal to CPCTC.
Yeah. You think you got it wrong for the
The last one you did, it's supposed to be HK is congruent to MJ. Because if you just put
MJ, yeah. Yeah, thank you. That, is that right now?
It's MJ.
MJ, for Michael Jordan.
Yeah, that makes
Jordan.
Michelle Johnson.
Michelle Obama.
Thoughts?
Well, could you say that HJ
HJ.
Okay,
HJM.
it's OJ.
MJ equals
OJ.
JK.
Oh my god.
And then is
Okay,
equal to
okay.
angle M, wait, yeah, M angle MKO plus OKJ,
What?
maybe?
You don't need to. Okay, OJ.
I don't think. Okay, so this is where my thinking's going just for a second. I can state this and this because of vertical angles, right?
Yes.
Is that going to help me at all?
That's what I think.
No?
Yeah.
MOH.
And the reason I was saying that is then I have an angle on a side.
It's not gonna help us prove that. That's a fascinating joke.
Yo, you can split the angle. You can split the base angle right there.
That's what I
So we know that this and this have to be congruent because of CPCTC. Ah, that's it. So this and this are congruent. So then we could then state that angle H. What? No. That. Wait. What are we trying to prove? I saw- We got it. So we could state this because of
Base angle.
CPCTC. So angle OJK is congruent to triangle or angle OKJ. And that's CPCTC as well. And once we've done that, that's face angle. So that's going to tell us that can't talk. Triangle JOK or whatever three-letter iteration they want is isosceles. And we can state that because we know we have the base angles are congruent, therefore the sides are congruent, and we're done. Oh my goodness. Wow. Yeah.
Instead of doing the OJK and OKJ, since we already know that HK equals MJ, could you have said OK equals OJ?
Say that one more time.
Instead of doing step 4, could you have said OK is equal to OJ? To do the segments instead of the angles?
That's where I was thinking for a little bit. I don't think I could state that right away. I think we could have gotten there, but Don would have gotten mad at me. What? Nothing.
Way to blame it on somebody else.
No, I'm just trying to look out for Don's best interest. It's all about Don.
Better be. JK. Maybe it is.
Let's get those notes out from yesterday that we had stopped. Where did I stop though yesterday?
In the beginning.
For the last.
In the beginning. Okay.
The second step.
Like on number 2 or something. Where, oh where? Come on. No ice cream today. Alright.
I think you want example proof too.
It's on freeze.
Oh geez. Frozen. All right.
Let it go. Now, y'all haven't done a road trip until you have the frozen CD in and you drive from here, Yellowstone, to Glacier, to Banff, back to here.
You drove to Banff?
Banff.
Banff, Canada? It's so nice.
Beautiful.
Very
Yeah, that was a road trip. So needless to say, on that road trip, as we were coming back across the border to the United States through Montana, we are like in like if I could pick the place where there was nothing, which proof was it did I stop on? Two. Okay. No, I did want to know that. So as I'm coming through in the middle of Canada, in the middle of Montana, like there's no one within 7 billion miles. I'm just being facetious, probably 7 million, but so the U.S. Customs agent's looking at my passport as well as my wife and my daughter's passports, and I'm listening to Let It Go, like nonstop. And he goes, so what were you guys doing in Canada? I said, well, we're up in Banff National Forest. It's beautiful up there. He goes, no, Banff is the #1 marijuana producing place in Canada.
Dude, that's
And I said, sir, did you see my license plates? And he goes, no, why? I said, I'm from Colorado. Why would I bootleg anything from Canada to Colorado? You sure? Sir, you have my permission to search my entire vehicle, just so I don't have to listen to this musical CD for 20 minutes. Hands it back to me. Have a nice day, sir. I think it became quite obvious that, one, if I did have something in the car, that poor soul driving deserves to have it. Because it was quite obvious going, I don't want to listen, please let it break. Yeah.
Did you know that 98% of Canada's population lives within, like, nearby the border?
Really?
Really?
Oh.
Because
so
it's
cold.
so cold farther up. That's why. Fun fact.
Fun
Wow,
fact.
that's
I'll take
so
it.
interesting.
All right. So yesterday I was able to do this really quickly in my last class. So let's just do this. So we have this AB and AD. We know that, and then we know this. And I'm not listing the givens because we already have it. I just want to waste space. All right. So how did I do this? I did it so fast yesterday. I'm so angry that I can't do it real fast right now. Shh. No, I got it. No, I got maybe. Shoot. I got it. All right. So AC and AC, and that's reflexive.
Mr. Stirrup,
What?
could you technically build your house on the four corners? Build a house?
I don't think
Well, I don't
there's
know. No,
any-
I can't because it's on tribal land, so I can't own anything on tribal land. All right. But Johnny, thanks for looking out for me. All right, so now we know that. Shh. So this is going to allow me to get to triangle ABC is congruent to triangle ADC. And that would have been just side, 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 right? Okay, how did I do this so fast yesterday? Oh boy, oh boy. Okay. I didn't crayon, that might have been a problem. Angle BAE is definitely congruent. BAE is definitely congruent. That's it. Oh, I got it. BAE is congruent to angle DAE. And that has to do with CPCTC. So here and here are congruent. And then I have to state that AE is congruent to itself. And that's another reflexive. So now that tells me this, and that gives me side angle side. So triangle ABE is congruent to triangle ADE because of side angle side. And I don't know why I was able to do that fast yesterday. It might have been the crayon. The triangle what? D. There's nothing for me at this point. But I probably was trying to prove that yesterday because it seemed like a good idea. So this proved 1, 2, 3, 4, 5, 6, 7 steps. Yesterday I was on my way to get to like 90. And then saying, oh, we already proved that. It's nothing better than proving a proof, and then you go back and show that you have already proven something that's already proven. It's always good. All right, that's as far as I can go there. We're done there. You may need to use both strategies, auxiliary lines. So remember auxiliary lines when we're adding a line segment, and detour proofs where we have to prove these triangles and then come back to get the other triangles or segments or things like that. All right. So what are things that we can do knowing that circle O is existing? What can I add? Go ahead, Sammy.
Like the radii.
Yeah. So I'm going to add this and this as my radii. Is that okay? I'm making it dotted because we're just going to start plugging it in. So from that, I can go ahead and say that OC is congruent to OB, and that's radii. Okay? And then now we know that angle B and angle C are congruent. That's fine. All right? So I then could go ahead and state, this is talking about this angle B up here. Let's talk about the other angle B. So I'm going to say angle EBO is congruent. EBO is congruent to angle ECO. Why can I state that this angle here and this angle here are congruent? It has to do with the radii. So what do we have because of the radii? What do we know? What kind of triangle is this here? It's isosceles. So we can state this because we know this. Therefore, we can state this. Yeah.
Couldn't you say line segment AC is congruent to AB because of like what you did with?
I'm gonna go there. I'm gonna go. Yeah. All right. So we know the red's congruent to itself. Then we can go exactly what you just said. We can go and say that AB is congruent to AC, and that's the same exact thing, stating this. But then I can state this, right? Oh boy. Oh shoot. Angle O. Prove that AO bisects BC. So okay. Oh shoot. What do you think? Yeah.
Can you just say that BE equals EC because of radii?
BE Equal, no, because this is not the center of the circle.
Okay.
It's a chord, and we have an interior point that we know of the circle, but the interior point's not the center. I do think, might get us in trouble. What? You know what I missed? It's a radius. Does that work? Let's see. So now that gives me, shoot. Got a side and a side. Oh, wait. Side. What is that? That triangle's congruent to that triangle. Oh, cool. Oh, thank goodness. All right. I feel better about myself already. I'm going to buy myself another ice cream today.
Wait, so
AOB.
like an ice cream too. When you
Yeah.
do auxiliary lines,
I'll meet
they
you,
don't
Dairy
write a
Queen.
statement.
AOB, AOC. Hang on. What do you say?
So if you draw an auxiliary line, you don't need to write a statement or reason.
I don't think you do.
Okay.
And I'm going to state this because of side, side, side. All right, that's good. I like that. Oh, fiddlesticks. Watch it. I'm using the big language today. Triangle. What? Say the other one. Sorry.
You can prove that triangle BAC equals
BAC.
AOC.
AOC.
Good job, Devin.
Oh yeah. Okay, so if I was gonna go ahead and say that, I think it would be important that I were to add BC is congruent to itself. We have reflexive. So this is good now. Oh boy, Devin, you were gone, but you did great. You're doing great for us. All right, so let's change to purple. I can put some more givens. All right. Oh shoot. Side. Oh my goodness. How are we gonna go this way?
Can you say that AC triangle ACE is congruent to ABC? Is that
Say that one more time.
Could you say ACE triangle ACE is equal to a
ACE, ABE. Oh wait, you might be on something. Hang on. Wait, did I mark? Wait. Time out. I'm onto it. I think. AOB. So no AOB. Oh. BAO is now congruent to CAO. And the reason I can say that is CPCTC. All right. Oh, what is this? That's angle side angle. There we go. Oh, that's ugly. It's ugly. I'm sorry. The reason I say that is definition of congruent parts or something. There, let's just leave this proof behind. All right, so you had 6 proofs on this homework. I just wanted you to start it. Yeah.
Yeah.
So what's today?
Wednesday?
Yeah, tomorrow. You guys did so well on the quiz. I need to bring your grades down somehow.
Wait, we have a test tomorrow?
I mean, when Johnny gets an A on it, you know it's too easy. Hey, Johnny.
Oh, it's okay.
What are these terms?
You know why? I'll tell you why. Johnny hasn't brought in cookies lately. Johnny, if you brought cookies in, we wouldn't have a test ever.
So you want me to bring cookies tomorrow?
No, I'm just giving you a hard time. All right. All right, we have time for one of those proofs on that worksheet. Yeah.
Number
Number
one.
one.
Five.
Number
Five.
one.
Five.
Number one.
Six.
Number
Six. Five or six. What are those two?
2.
No.
I like 2.
Six. Six.
All right, the debate's over. Is that a Q? Yes, it's a Q. All right. We are going to try to prove MQP. This angle here is congruent to this angle here, right? All right. That's where we're getting to. Let's start putting some givens. Givens will be in green. G, givens, right? MN. And here. Those are congruent. And I know MP is congruent to this. All right. So we have an angle on an opposite side on one of them. What do you think? We're trying to get it to the red as congruent. So things that I might know.
Auxiliary line.
Yay?
Yay. Yay.
So by me drawing this in, I can do that this is congruent to this. Why? Because what? The reason we can do that purple, so angle SMP is congruent SMP to MSP. MSP. Because of this. Boom. We know this. Right? Okay. Shh. I'm going to do a triple angle here. 1, 2, 3. 1, 2, 3. Why can I state that? To get the exact same reason. So then I can say that angle NMS is congruent NMS to NSM. Because we know this to this. Okay? Thoughts? QN is congruent to itself, so that gives me an angle, or side to side. QP is QP, that gives me a just a side. Side to side. I gotta think through number 2. I'll tell you what, if number 2 is on the test, we do it as a group and y'all keep quiet, right?
Yeah.
Okay. But if number 2 is not on the test, then you gotta do the whole thing by yourself.
Number 2 on the test.
Number 2 on the test, I will make number 2 on the test your name.
Okay.
Who is the guy who brings cookies in
I'll
to
bring
class?
in cookies tomorrow for you.
That would be Johnny.